Hey guys, Brendan from TAT. Today I've got an Amarok with DPF issues. So we've got a Volkswagen Amarok here, 2012 model, 2-litre diesel with the CSHA engine. Complaint is a check engine light. So they were driving along on the highway and no DPF light, just the check engine light came on. But when we read the codes, we get P2002, and that's diesel particulate filter efficiency. So I mean, first thing that we confirmed is great, they were on the highway, so if the particulate filter wanted to regenerate, it had a good chance to do that. If anything, that might have been what it was unhappy with, that it couldn't complete the regeneration even though conditions were great. With this code, a lot of manufacturers will treat it very differently, so it's a good idea to try and come across the code setting criteria if you can. In this case, not being familiar with it, how they treat it on the Amarok, I paid the small fee to go onto the VW information portal, that's called Irwin, and I was able to go in there and see what the code setting criteria was, which helped me to direct what I was going to start testing first. If you want to find the link to that and other manufacturers, you go to the TAT homepage and you would head to the OEM info resource tile, and that'll have listed out all kinds of information like that for different manufacturers. Very small fee, I think it was just over $10 or something for an hour's access, and really helped me with this. So I'll show you firstly the freeze frame of the data, and that gave me good direction, and we've found what the problem is, so hold on. So this is using the VCDS Rostec scan tool dongle that you use with your laptop. Very good for any VW stuff. And we can see we've got our fault code here. I'll use my finger for you. So P2002 efficiency below threshold, particulate trap, bank 1 efficiency below threshold. So it gives us some good information when it's set, but also a bit of freeze frame data here, and it was quite helpful. So the things that I noticed were we're at 2000 RPM, we're doing 95k an hour, and we have quite low pressure. So our particulate filter is only 22 hectopascals, or that's equivalent to 22 millibar, which is quite a low pressure for something that's quite high load. So a lot of people associate DPFs with getting blocked up, but in this case we may be dealing with the opposite. The other thing that struck me was the soot mass measured is a negative as opposed to the soot mass calculated of 13 grams. So to the best of my knowledge, I believe the way VW does it is the calculated is a theoretical value, say based off how long the car's been running, what speeds it's been at. It comes up with a number of how much soot it thinks should be in the DPF at that point, whereas measured is it using its sensors. So for things like the pressure differential sensor, it's going to measure these and come up with how much soot actually is in there by its measurements. So interesting that for the amount of driving that's been done, it thinks it should have 13 grams, but it actually measures out that technically it's got negative grams of soot in there. I can see that my sensors were working at the time, so that's great. I've got no reason to suspect an intermittent issue with these temperature sensors. Can't see number 1 and 2 there. That's not ideal, but at least we've got something to follow here. So when I looked up the code setting criteria, it did mention that the way they do efficiency on this Amarok is they're looking for a pressure that is either too high or too low for the MAF flow that you've got. Although they don't particularly respond to it as MAF flow, they call it exhaust gas jet volume in particulate filter. So that will be based on the MAF reading and the temperature of the exhaust gas. It slightly varies the actual flow, but for all intents and purposes, the major input in that is going to be your MAF reading. So I'll show you the testing that I did and what we've come up with. Sorry it's a little bit hidden down there, but we're dealing with our differential pressure sensor here. So this can be a common cause of this fault on VWs, particularly with this sensor failing. It wasn't the case in this time though. So what I did was, you've got 2 hoses going to it, obviously one before the DPF, one after. Firstly I was looking at the scan tool and I could see it did have quite low pressure. So key on engine off, it was 0 millibar. Idle, we were only just tipping about 1 millibar. It's kind of going 0 to 1 millibar. And at 2000 RPM I was just able to achieve about 3 to 4 millibar. Very, very low. If you were to convert those to kPa or PSI, you'll realise those are extremely small numbers. Generally you want to see at least some back pressure there, but we don't want to see too much. So some rules of thumb: at idle, shouldn't want to see more than say 10 millibar at idle, and at 2000 RPM we shouldn't see anywhere near say above 50 millibar. Some people even say 30 millibar. That really depends how much, at what stage of blockage the thing's at, because it could be getting partially blocked and it's just ready for a regen, in which case yes, you may be approaching a higher number, but definitely you don't want to see it over 50 millibar at 2000 RPM. So in this case, this thing is reading, but reading hardly anything. So first thing I did was popped off these two hoses, and I put a smoke machine on them just to make sure that they weren't cracked further down the line or anything like that. That was fine. I had smoke coming out the exhaust, blocked the exhaust then, so we got a bit of pressure in the lines, no smoke coming out of them. Then with them disconnected, I put on a manometer and measured the actual pressure that I had at these pipes. So we wanted to make sure that it correlates with what this is actually reading on the scan tool, and yes, it did. And then just to cross all of my T's and dot all my I's, I got a Mighty Vac, just pumped it up onto this sensor, and whatever my Mighty Vac read, that's what the sensor read on the scan tool. So this guy is absolutely great. He's passed with flying colours basically, and you know, I have no reason to suspect that I can't trust its readings at this point. So armed with that knowledge, I started thinking, okay, well, we've got good readings here, we've got pipes going to it, but we don't have much pressure in the DPF. I really need to basically physically inspect this DPF. So I'll show you what I found.
So this is the back side of the DPF, and you can see we are inside a crater. If we come back a bit, and you're sort of looking at the internal walls there, I'm going to start coming back. You can see we're now sort of looking more at the face of the DPF. Obviously something very wrong, right? So if I come back, you'll see I was just inside the exhaust there, and now we're out. So we've definitely got some problems.
So we're very ugly back to the DPF there, and that must have internal openings that are flowing too much basically. So interesting that they're able to see the pressure isn't enough there. That's how they're going to catch out if someone was to try and, you know, knock the guts out of it like they used to with an old cat sort of thing. Interestingly, I looked at the front of the DPF, quite difficult on this because you've got one block with the cat and the DPF, very small gap of a couple of centimetres in there, but pulled out the temperature sensor, got the camera in there, and I was able to just see the face of the DPF. Wouldn't have been able to come to that conclusion though. It didn't look too bad. At the back I was able to pull the actual pipe off, get a really good look at it, and obviously we've got that. So the question is, why has it done that? As always with DPFs. So there's a bit more to the story once I spoke to the customer and said, hey look, we've got this problem. Apparently this had a DPF light previously. He says a couple sensors got replaced, got him to work out which ones they were. They were temperature sensors, and looking at them they look quite new. So I have to theorise what's probably happened, but I imagine this probably had a failed temperature sensor, loaded up the soot in the DPF as it wouldn't have regenerated with that failed sensor. Whether naturally it's got to the point there was that much back pressure that's created a lot of heat, or whether someone's doctored to try and do some forced regens or whatnot, but no other running issues on this car. I'm fairly confident that there's no reason for the DPF to fail now, and it was likely to do with the temp sensor, and maybe someone got a little bit overzealous with a bit of heat basically. So this is going to get a new DPF, obviously mechanically failed. I will be replacing that differential pressure sensor as well. They're about $90 genuine from VW. If you're going to spend thousands of dollars on a DPF, it's basically a sacrificial wear item at that point because they are very common to fail. So that will get this one sorted. So P2002 DPF Efficiency. Like I said, a lot of different manufacturers will treat it different ways. Nissan commonly will set it when they have failed temperature sensors. But by the look of this Amarok, pull off that rear exhaust pipe and have a look, just make sure we don't have damage to the DPF causing excessively low pressure. If you want more tips like this, so I'm going to log a repair solution for this one on www.tat.net.au. Thousands of members putting up tips all the time. Something like this could have been quite tricky to get to if you've never come across it. Hopefully this will help someone out in the future. Thanks guys.